Let's do problem 10. Never pass up the Tarzan problem. When we breathe, we're expanding our lungs, which decreases the pressure there. So we have high pressure out here, low pressure in here, and the air just moves from high pressure to low pressure. So you're not like sucking air in, it's rushing in. You can't not rush in when you expand your lungs. Frogs breathe the other way. They create a positive pressure. They are pushing air into their little lungs. Who cares how frogs breathe? The gauge pressure in each of the 4 tires on an automobile is 240 kilopascals. If each tire has a footprint of 220 centimeters squared, estimate the mass of the car.
It doesn't seem like there's enough information.
I know.
But I'm sure there is.
But there is. There is. As a kid, I never laughed so hard in my life as the time we tried to float the kiddie pool in the big pool, you know. And it started sinking. Alright, it's fun. This is where it all gets good. This stuff is all, yeah, you know, low-level stuff. We want to think about interesting problems, like how many people you can fit on a raft before the thing sinks. Stuff like that.
Yeah, that's pretty exciting.
Oh my god. What's that radius? Oh, no, I can tell you this. See, they always give us diameters, yeah. So I don't like to use this radius then. You know?
Atmospheres.
Yep. But you have a reference table that converts the atmospheres. It's just atmospheres to pascals is the simplest thing you can do.
Yeah, I did.
Times 10 to the 5th.
Yeah, I didn't do that.
No problem. Can we get on Archimedes? Buoyant. You know, floating type. Doesn't have to float, but uplifting force. When an object is floating, then the buoyant force is equal to the weight of the object. If the object sinks, then the buoyant force is less than the weight of the object.
What if it's more?
If the buoyant force is more than the weight of the object, then it floats.
Does it fly out of the water?
It doesn't fly out of the water, it just floats higher in the water.
What if it floats above the water?
Then it's out of the water. And at which point there's no buoyant force that we care to measure. The buoyant force on us from the air that we're submerged in is not significant. Now, if we were a helium balloon or something, and no, this works beautifully for a strangely shaped object. Here's an object. I have no idea if I've selected the right block A. 23 grams. And I know you've all done this with a kickboard or a ball or something. You hold it under the water and let it come shooting out at some kid's chin.
Is there a case where it's not submerged in there?
Right. Not the balloon. But when we do like rafts in water and stuff like that.
Oh, right. Well, if there's water involved.
Yeah.
Common sense.
When?
After school today.
Great.
I was thinking.
Get down here early. 1 gram of oak.
Yeah.
It's floating. What else?
Radius. That's
The radius. Yeah, I'm talking forces here.
That's a force.
Yeah,
What? How much helium's in there? We don't know. It's okay.
What is making it float? The force of buoyancy. What is the components of the force of buoyancy? And what are the components?
Gotcha. I know exactly what you're asking.
You know what?
Yes, I know what you're asking. Give me a chance to answer it.
Oh. Well, why'd you acknowledge the fact that you knew what I was asking, but not...
So that you would stop elaborating on your question. The aluminum will sink. The fluid we're talking about in this case is air. That mixture of gases that we're all submerged in. Did it mess you up that this problem didn't involve water? Come on. So which is the bigger value? 1 kilogram of iron or 1 kilogram of aluminum? Aluminum. Should I get out my little density blocks?
Yes.
No?
So the aluminum.
This is aluminum. I don't have iron.
I'll tell you when you're older.
Too bad. See, all of these have equal mass.
We're supposed to believe you.
Yes. These all have equal volume. So, say this was iron, though it looks like more like nickel, but similar to iron. Alright, it's only a couple over.
You need a drop of water.
I could, but you know, this is a Monday.
Then they'd all be wet.
Alright, so we'll say aluminum on that, alright?
That didn't prove anything. You just clicked them together.
No, what I'm trying to say, you don't understand. If aluminum... 1 gram of oak. You familiar that oak is a type of wood?
Yeah.
Oh.
Don't call this out. Can you just consider? Certainly be on a test. Why not?
You should make a test with just these questions.
Your scores would be horrible. Yeah, so which of those is a bigger number?
Probably.
I don't want any probablys.
Alright.
1 cubic centimeter of oak and 1 cubic centimeter of aluminum are dropped into a pool. Which has the largest buoyant force on it? Did you get it or not?
Wait, I have a question.
Oh, we're getting to the good questions. Okay, man.
Why was the one before that about the cubic centimeters?
Oh. This one?
No, the one before.
This one's the one.
No, the one before that one. It was the one where no, it was the one between the aluminum and the iron.
Okay, here we go now. Now we're gonna see. Now we get to the good stuff.
Ice.
Ice.
Oh, yeah.
Can I write the equation for density using a D? Like it
No.
comes off of that.
You wouldn't get points off for it, but it would just irritate me. Which could result in points off somewhere else.
What does D stand for?
D?
Why can't we use D?
Little d?
Any D.
Little d stands for... Alright, so explain this to me.
We don't know the mass or the...
Are you going to explain it to me?
Ice.
I'm guessing.
Darn. Yes.
Yes. So just take that information and do the logic that I don't feel like thinking about.
Alright, one last one. You are on a float in a pool using hand weights. Fun to do, why not? You don't play with those little weighted thingamajigs?
So I'm working out in the middle of the
The weights fall overboard. Does the pool water level go up, down, or stay the same?
Depends, are the weights made out of water?
Oh!
No, it doesn't depend on anything.
Shouldn't it go up? Because it's replacing its mass when it's above water, but replacing the volume. when it's
Because if it went
Wooden
down,
weights.
you'd be like, what the heck just happened?
Alright, if you're using wooden weights, no. Alright, so...
Yeah. Mr. Sommers, if the level went down, you could just drop like infinite weights in there and then there'd be no water left.
Spectacular.